Hello, sixth graders. We're going to go over your study guide. So hopefully you have turned it in before the start of the class. You can always unsubmit your study guide without penalty if you want to change or need to change anything as you watch this video. All right, here we go. Number one, true or false? Skater B will have the most kinetic energy when released. So you have the two pictures of the skater where the skater was at this position, and then you had another picture where the skater was uh, down a little bit, maybe like right here, and which position did the skater have most kinetic energy when released? Uh, it would be skater A. So the answer to this is false. So skater B does not have the most kinetic energy when looking at those two pictures when released because skater B is not as high up as skater A. So when we start skater A here, notice the kinetic energy. And if we were to start the skater, get the bar graph, if we're to start the skater down here, notice that kinetic energy bar does not go as high than if we were to start the skater up here. So the skater higher up has more kinetic energy, and that was skater A, than putting the skater down here and starting the skater. See, that kinetic energy bar doesn't go as high. Okay, let's take a look at number two, true or false. Stretching out a rubber band as far as you can will decrease its kinetic energy when released. Explain why or why not. This one, again, is false because the farther you pull back a rubber band, the more potential energy it has. Therefore, the more kinetic energy it will have when released. So we learned in a lot of different investigations, the rubber band, the pullback car, that when we pull something back and we give it more potential energy, it will have more kinetic energy. It will go farther. It might go faster. True or false? Toy car B will have greater kinetic energy when released. Explain why or why not. So you have pictures of two different toy cars. One was pulled back on a metric ruler, a certain amount of centimeters, and then the car in letter B was pulled back even farther. This one is true because the farther the car is pulled back, the more potential energy the car will have. Therefore, the more kinetic energy it will have when released. Okay, skater starts at point A. At what point would his energy bar graph look, or his energy graph look like what's shown in the bar graph? Okay, so let's start this skater up at point A. We notice that the skater has all potential energy. Before I start, I want to put slow motion on. All right, and we want to see the potential and kinetic energy be just about even. So we'll let it go. Oh, and there it is, just about even. And I think that matches letter C closest. So point C, because that is where the skater has lost the same amount of energy. So it lost energy, lost its potential energy as it has gained kinetic. So they are even, okay, at about point C. Okay, at what point will the skater have the greatest potential energy? At what point will the skater have the greatest kinetic energy? All right, so let's put the skater up here. That is at point A. And so the answer is point A because we can see in the bar graph that the potential energy is at its greatest and there's no kinetic energy. So as the skater goes down, this would be point B. We see potential energy decreasing, kinetic energy starting to increase. This is point C, so less potential. Point D, even less. Point E, just a little bit of kinetic energy. In fact, this skater is probably not as far, it's probably a little bit farther down than the skater over in your study guide, but we have almost no potential energy at E. So again, the greatest potential energy is at A, and at point E, the skater will have the greatest kinetic energy. So let's take a look at that. We see kinetic energy increasing. There it is, point E. We have the bar for kinetic energy the greatest. Okay, so which speed indicator? So let's take a look at our speed. And we'll put, speed, grid, bar graph. Okay, which speed indicator correctly matches the energy bar graph? So the energy bar graph has all potential, no kinetic. And speed indicator D is this one right here, where it's at 0. So let's place the skater up and all potential. So if we let the skater go, we can see the speed dial going up. So the speed of the skater is increasing, and therefore the kinetic energy is increasing. All right, kinetic energy is starting to decrease, potential energy is increasing. Oh, and the speed is dropping as the skater is going up the hill and gaining potential but losing kinetic. All right, so there we have it. Letter D is where the potential energy is the most, kinetic energy is the least here. This means all of his energy is potential. Skater is at the top of the hill, as we can see. All right, potential energy is transferred to what kind of energy? When an object at blank is put into blank, potential energy is transferred to kinetic energy when an object at rest is put into motion. So potential energy is when an object is not moving, but it does have the potential to move. It's got stored up energy. It's at rest, but it's got some stored up energy due to gravity or due to elastic, stretching something back gives it potential energy. And when the object is put into motion, that's when the energy is transferred to kinetic. Number 8, why does a bike resting at the top of a 100-foot hill have more potential energy than a bike resting on top of a 10-foot hill? The bike at the 100-foot hill has more potential energy because it is higher up above the earth. We learned that with the blocks and the boards when we slid the blocks down the board. The higher up we raised the board, the faster the block went. And therefore, it had more kinetic energy. And it had more potential energy the higher up it was before it was released. All right. Number 9, when we watched the skater in the skate park, we noticed that the total energy never or always changed. Why do you think this is? So let's take a look at our total energy bar. We're going to see potential and kinetic changing. Let's see what happens to the total. It does not change. So total energy never changed because energy was never lost nor gained. It's only transferred. So the total amount, whether it's kinetic or potential or a combination of the two, stays the same. It just changes from one to the other. That's it. That's the end. All right. Don't forget to study your study guide. You can rewatch this video. You can also go back into the skate park and see the skater do some different things, but make sure you've got the bar graph on, you've got the speed on, so you can see what happens to speed as kinetic energy is gained, or you can watch speed as potential energy is gained. All right, you can learn a lot from this. If you think you're well studied, you can go onto the playground. You can make a different kind of ramp for the skater and kind of try out some different things. So that's kind of fun too. You do have a Kahoot after this that's going to be uploaded onto Google Classroom by the time you're done with this video. So go to the Kahoot in Google Classroom. It's uploaded for Tuesday and play the Kahoot. It is at your own pace.